Hi everyone, welcome back to Cybersecurity Simplified. Today's AI-103 question covers a concept that many people get wrong when building AI applications: RAG versus tools. Many teams think if I put data into a vector store, my AI will always know the latest information. That's not true. Today we'll learn what RAG is good at, what RAG cannot do, why agent tool exists, real Azure AI Foundry demo, AI-103 practice questions. Let's imagine we are building an insurance claims copilot. The assistant needs to answer different types of questions. Question 1: what is the insurance claim process? Question 2: what is the current status of claim XYZ? Both sound similar, but they require completely different solutions. RAG is nothing but stored knowledge. Think of RAG as a digital library. We upload documents such as which contains insurance claim process, 1, submit claim, 2, upload document, 3, adjuster review, 4, decision, 5th, payment. Now if somebody asks, what is the insurance claim process? The answer already exists in the document, so RAG works perfectly. Next, tools is nothing but live data. Now let's ask, what is the current status of claim XYZ? Claim status changes all the time. For example, I'd say 10 a.m. under review, 10:15 a.m. approved, 10:30 a.m. payment processing. A document uploaded either may already be out of date. This is where tools becomes important. Tools can retrieve information from SQL databases, APIs, CRM systems, ERP systems, business applications, etc. Memory trick: RAG, what we know. Tools, what is happening right now. Before we answer today's question, let's see how this works in Azure AI Foundry. We are going to build a very simple insurance claims copilot. The goal is to demonstrate three concepts: system instructions, knowledge, which we call RAG, runtime data. I'm in Microsoft Azure Foundry. Let's deploy model. Deploy using default settings. It is deployed 5.5. I'm going to add following system instructions. Basically, we are telling our model to behave and act as an insurance claim assistant. Notice what we are doing here. The system instructions are not providing knowledge. The system instructions are simply teaching the assistant how should it behave. Think of system instruction as the rules of the assistant. Now let's upload our first file. Note here, it gives index option and vector index name. Files we upload, it will get indexed in our vector index database. This file has simple steps. When status is success, it's attached. See, when I upload this file, Azure AI Foundry, take that document, chunk it, embed it, and then vector index it. The file becomes searchable. This is classic RAG. Think of this as stored knowledge. Now let's use our first prompt. The assistant answers successfully because the information exists in the vector index. This is exactly what RAG is designed for. The answer comes from the stored document. Let's use some real-time data or prompt. Notice what happens. The knowledge base doesn't contain any claim status information. Our document only contains the process, so the assistant cannot reliably answer the questions. This is the limitation of RAG. RAG only knows what exists in the index documents. Now let's upload second file, enable code interpreter, add file. Here, if you see, there is no index, no vector index, nothing. This file contains some real-time data which we are feeding as a demo purpose. Once successful, let's attach it. Now in this demo, I'm uploading a file manually, but this is important. In the real enterprise environment, we would not manually upload this file. This information will typically come from SQL database, REST API, SAP, Salesforce, claim management system. For learning purpose, we're using a file to stimulate runtime data. Why I'm using code interpreter? The first file was uploaded as knowledge base. It was indexed and stored in a vector database. The second file is different. Think of it as behaving similarly to what an agent tool would provide. The important idea is knowledge file is indexed vector search, but runtime file is current operational data. For our demo, the uploaded runtime file is acting like a simple stand-in for a database query or API call. Let's use the same prompt again. If you see, now the assistant responds. The answer did not come from knowledge document. It came from runtime data we just provided. Now let's ask a more realistic business question. Now you see the response. It shows current status plus process guide and all that thing. If you see, now the assistant combines two sources, knowledge, the insurance claim process, and the runtime data. The response includes current status plus process guidance. This is much closer to how real enterprise AI application works. Question. A team suggests relying only on a vector indexed exports from SQL, but reporting must reflect the latest transactions every minute. What is the best architecture correction? We have option A, keep vector only retrieval because embeddings are always real time. B, use agent tools for runtime SQL queries, optionally combined with retrieval context. Move the logic to the system prompt so the model infers current balances. D, replace SQL access with Azure monitor logs. Let's eliminate option A. Keep vector only retrieval because embeddings are always real time. Let's eliminate this first. In our demo, we uploaded insurance claim process into knowledge. The document was indexed and became searchable. But here's the problem. If a database exports were generated at 4 p.m. and a claim changes at say 4:1 p.m., the vector index is really stale. Vector store knows what was indexed. They do not magically know what changed afterwards. So option is out. Option C, move the logic to system prompt so the model infers current balances. Let's eliminate this one too. What do system instructions do? System instructions control behavior, tone, rules, response styles. They do not create live business data. Option D, replace SQL access with Azure Monitor logs. Azure Monitor is useful for monitoring, logging, diagnostics, observability, but it is not the primary source of transactional business data. If we need the latest claim status or latest transaction, we still need access to actual business system. So option D is out. Correct answer is B. Use agent tools, functions for runtime SQL queries, optionally combined with retrieval context. Why is this correct? Look at the biggest clue. Latest transactions every minute. That's Microsoft telling us this is live data. Live data usually requires SQL queries, APIs, function calls, agent tools. Exam tips. When you see current balances, latest transaction, real-time inventory, current status, live information, think tools. When you see policies, procedures, manuals, SOPs, historical information, think RAG. Final memory shortcut. RAG, what we know, tools, what is happening right now, system instructions, how to answer. Before you go, I do love to hear from you. If there are Azure AI Foundry, agents, RAG, prompt engineering, evaluation matrix, GPT models, AI-103 topics you'd like me to turn into future practice questions, leave them in the comments below. If something in Azure has changed or you have a better real-world example, let me know as well. Your feedback genuinely helps me create more useful, practical, and high-quality content for the community. If you found this video helpful, please like, subscribe, and share it with others preparing for AI-103. Thanks for watching, and I'll see you in AI-103 practice question 15.